Here we go, relations and functions, lesson 4, intercepts. The most important thing that you can think of when you're hearing the word intercept, I want you to think of 0. The number is 0. Because when you're working with intercepts, 0 will always be one of your coordinates. So the other way that you can think of it is whenever you see a coordinate of 0, you should be thinking intercept. If you've got the x-intercept, you'll have a value for x and the y-coordinate is 0. Okay, just like we saw in those tables before. If you've got the y-intercept, you'll have a value for y. So that's how you know what kind of intercept you've got. Look at which one you've got a value for when the other coordinate is 0. And the x-coordinate will be 0. Okay, and then we know that in linear functions, the y-intercept is also the constant in the equation. Okay, and by constant I mean this. It's not attached to a variable. Okay, so when we're finding the intercepts, when we think of 0, to find our x-intercept, we're going to substitute in 0 for y. So we'll go 0 is equal to 4x minus 8, and then we'll use algebra to solve for x, and then we'll write it. Okay, and we should write it as a coordinate pair. So when x is 2, y is 0. Okay, to do the y-intercept, we'll do the opposite. We'll make x equal to 0 in the equation, and we'll get the value of y. This is easier to do. Okay, so that's what we're doing here, and then you can draw the graph. And then if you've got those 2 points, so we've got our x-intercept of 2 and our y-intercept of -8, then we can use that same pattern, meaning that we'll move up 8 and we'll move over 2. So that's why here we'll move up 8 more points and we'll move over 2. Okay, that's what we're doing right here. So here, to get the y-intercept, you actually don't even need to do it. I just showed it here, but look, we know if the equation's given in this formation where we've got an x value and a constant, then that constant is the y-intercept. If there is no constant, then it's 0, and then that would mean your y-intercept is at 0 at the origin, so that would be both your x and y-intercept. So hopefully that kind of makes sense. Okay, sometimes they can both be happening at the same point. It happens sometimes, not all the time. Okay, so here our y-intercept is 2. To get our x-intercept, we'll substitute in 0 for y and solve for x. Okay, same thing here. Find the value of k. So here we would put k, the constant, right, will be -5 because that's the y-intercept. Here the function has an x-intercept of -2. So then we can write out this coordinate pair here. So when x is -2, the y value is 0 because it is an x-intercept. Find the value of k. So then we can substitute in 0 for y and -2 in for x and solve for k is what we're doing there. It's a bit confusing. Okay, so we know this point right here, given this x-intercept. We've got the function, so we can replace the f of x with y, 3x plus k. Now we'll use these 2 values as our x and y values. So x is -2, y is 0, and then we'll solve for k. Okay, so we've got 0 is equal to -6 plus k. Now we'll isolate k by doing the opposite operation to both sides. Here, write the function to represent this, where we've got our cylindrical tank draining, so that's why it's going down, because it's going to have a negative slope. And here, so we're starting with 45. There's that 45. That's our y-intercept. That's our constant. And then our slope is for every 1 minute. So for every increase of 1 along the x-axis, we're going down by 5 units on the y-axis. Okay, and you guys have seen slope with rate of change in grade 9. So slope is equal to rate of change, which is equal to the change in y over the change in x. That's what those little triangles mean. And maybe you've seen those in science before too. Okay, what does each intercept represent? So the y-intercept, or the volume, represents the total volume of the tank, and our t-intercept, or our x-intercept, represents how long it will take the tank to drain. Okay, for our domain and range here, if we look, this is a real life problem, so we have to match it to that. Our time, will never go into the negatives, right? Because we can't go back in time, and it stops at 9. So that's why we say time is greater than or equal to 0, but less than or equal to 9, all real numbers in between. For our range, that's talking about our y values. It's never going to be higher than 45, and it will never go into the negatives. So that's why we use this. Our volume is greater than or equal to 0, but less than or equal to 45, all real numbers. Okay? Here, again, this is just word problems. So hopefully by going through the answers when you're filling it out, it made sense to you. And that's it for lesson 4. We're going to go into lesson 5 next.